Okay, so what I'm going to show you is a little bit about human space flight. And I will tell you up front, and I'll keep telling you, that every picture that you see was taken by a human being, including this picture of the Earth. This picture of the Earth was taken during Apollo 15 by someone who was orbiting the moon. Now, I could tell you about the Mercury, Gemini, and Apollo things, but I'll tell you mostly what I did, which was fly the space shuttle. Before 1981, from 1961 to 1981, all spacecraft were used only one time and then thrown away. Because when they came back through the atmosphere, they were very severely burned. The space shuttle was designed to be used multiple times. The material on the outside of it protects it from being burned. It launched like a rocket. It flew, it's a real picture of the space shuttle, from space, flew like any other capsule or satellite in orbit, and then at the end of the mission came back and landed on a runway, but it had no engines. So it was a glider as it came back to land. So I had the opportunity to fly on board the space shuttle 5 times. This is me here in the space shuttle, and that's the way we launched and landed. We wore this big orange suit and helmet, boots, parachute. All of that weighed almost what I weigh. So it was pretty heavy stuff. We used the shuttle over its 30-year history to do a number of things. We took experiments to orbit, we took satellites, we took the Hubble telescope to orbit. The crew is up here in the windows, and everything we took to space is back here in the cargo bay. So for the last 10 years and 37 flights, the shuttle flew 135 times. The last 37 flights, we built the International Space Station. And we built it one piece at a time. So the piece would be carried here in the cargo bay. And then here were the first 2 pieces of the space station. And then over the years, as we added more parts, we added these are solar arrays. You can see a mechanical arm. We moved the solar arrays around. And each time the shuttle showed up, this is a real picture of the shuttle attached to the space station. Not a picture, not a cartoon. There's the space shuttle, and there it is attached to the space station. And as we built it, it got bigger and bigger until this is what it looks like today. We put our first crew on board the space station at the end of the year 2000. The crew stays on board for 3 months or 6 months or a little longer, and so there's always been somebody in space on the space station since the end of the year 2000. So here it is, what it's like to be in space. Okay, so that's me. And here's what happens when there is no gravity. And in case you were wondering how that picture was taken, here's how that picture was taken. So let's talk about having no gravity. Without any gravity, there is no up. So each one of these crew members thinks they are pointed up. When we had the shuttle attached to the space station, we could have 10 people on board. Today, there are 6 people on board the International Space Station. These are the 6 people that are on board today. So we have 3 Russians, we have a woman from the Italian Space Agency, and we have 2 Americans, and an American and a Russian will spend a year in space, which will be a long period of time for them. So these 3 guys will be coming home in about 3 weeks. Without any gravity, you can hold up a very heavy weight with a single finger. And without gravity, you cannot walk, you must fly. Doesn't that look like fun? Okay, so here's the way you do that. You notice you never see them stopping. Here on the Earth, when you walk, you stop. You want to walk, you want to go faster, you run, or you walk faster. When I am flying, I push off from where I am, and I head to where I'm going. And if I push off too hard, I go right past where I'm going. If I don't push off hard enough, I don't get to where I'm going. And if I push off at the wrong direction, I crash into the wall. So now we know why Superman flies with his arms out in front of him. Just by moving your body, you can do some very interesting things while you are flying. Please do not try this at home. If you've studied physics, you know that for every force there is an equal and opposite force. So if you are floating, imagine if you get hit by a very heavy object. So here is me, and I'm not going from one point to another, I'm just staying in one position, and just by moving my hips, I can turn completely around. Here's the demonstration of the ice skater. And without gravity, you can spin and never get dizzy. So as he spins, he raises his arms, he slows down. When he closes his arms, he spins up. So you see, physics still works. And here's another one. Please do not try at home. Now see, he can't do it as well as I can because he's a guy. The guys just can't do it all right. Here is one crew member using another crew member like a surfboard. So you've seen people floating around. What if you want to stay in one place while you're working? While I'm floating, if I type at a key, if I push the key on the keyboard, I float away. And so in order to stay in one place, we have these straps that are attached all around, so that if you want to stay in one place where you work, you slide your toes underneath the straps and you stay there. Or she's got her toes grabbing around the bar so she can stretch across the aisle. This is a ball of water. And without any gravity, surface tension is the strongest force there. And so liquids will form big balls. Here is a ball of orange juice. So here they're making the ball of water. He squeezes the bag, and out of the straw comes the water. You can see little balls are floating around it as they break off. Now they're adding a lot of water to the bag, to the water ball. Now he's taking a GoPro camera and he's pushing it into the ball of water and turning it on. So here's what it looks like inside the ball of water, looking out. Now look at the water on his hands. See, the water sticks to his hands. He can move his hands around, and the surface tension between the water and his hands just keeps it stuck to him. So keep that in mind. So here's a ball of water that gets hit by another ball of water. All right, what do you do with the balls of water? That's not normally the way you drink. You saw the drink bag in the video before that. The bags have, if they're empty, you fill them up with water. If you want something like juice or coffee or tea, you find the bag that has the right powder in it. So this bag says orange juice in it. You fill it up with water from a dispenser that's in the wall. Sometimes the crew just drinks directly out of the water dispenser. Our Italian crew member, they sent her an espresso machine. Now she has fresh coffee, and she's got her own little specially shaped bag. In fact, she has her own little cup. So this is a very uniquely formed cup, such that the shape of it allows the liquid to stick to the sides so that you can drink from the cup without using a straw. So they are just testing this. It's not just to have fresh coffee in a cup, it's all science. There is no oven and there is no refrigerator, so the food is already cooked and it's been freeze-dried and vacuum packed. So the air is taken out, the liquid's taken out, and it's in these little packages. Just like the drink bag, you put it into a dispenser and you push the button for hot water or regular temperature water and you fill it up. Then you put it in a heater that warms it up if the food is supposed to be hot. On board the shuttle, you can see his feet are in those straps. He has a tray tied around his leg, and then all those little white squares are Velcro. So each food package has a little piece of Velcro on it that sticks to the tray, and then his drink bag floats right out in front of him so that when he's ready, he can just put his mouth on the straw. On board the station, there is a table which has a bar underneath so you can hook your toes. And then there are straps on the top of the table that hold the food packages to the table. You can see they're eating with really long spoons to get in those packages. And all these little plastic bottles in the back hold liquid salt and liquid pepper and liquid spices. Because you don't want salt and pepper and things to float around. In fact, you don't want your food to float around. Imagine things like a cracker or a cookie that makes crumbs. So we try to take foods that have no crumbs. So this one is nearly the perfect space food, peanut butter and honey. Here's peanut butter and honey on a piece of bread. The Americans provide half of the food and the Russians provide half of the food. Here's the Russian food. Yum. Of course, the Americans don't always do much better. This is creamed spinach. That looks gross. Here is a piece of meat. Meat is not freeze-dried, not vacuum-packed. It's in that package with all of the liquid. It's already been cooked. You warm it up in your oven, and then you cut the top off, and instead of using a plate with a knife and a fork, you eat it sort of like an ice cream cone. So you hold onto the package, and you eat your meat, and when you want more, you squeeze the package at the bottom, and up comes the meat. And there's the little dispenser for salt. So the crew has gotten sort of creative with their food. This is a space hamburger. We have a tortilla that is clipped off to the wall with a Velcro clip. And then we have mustard and ketchup, and the surface tension between the mustard and the ketchup holds the meat onto the tortilla. Another version of that, the meat is broken up. This is squeezed, spread cheese and chili paste. Sometimes the crew uses chopsticks because they're a little cleaner than the spoon, and you can get into the bag and pick up your item with the chopsticks. In fact, you can hold up very heavy objects with a chopstick, like a grapefruit. And if you want, you can even drink your coffee with chopsticks. So you see, squeezing, just like we made the water ball, he's squeezing the bag, and then the surface tension between the coffee and the chopsticks will hold it. It takes a long time to drink your coffee with chopsticks. When on the earth here you want a piece of fruit or a vegetable, you just get it. It's available, it's in your markets, it's in your homes. But imagine that you're on a space station and you only get a resupply vehicle every 3 or 4 months. So 3 or 4 months is the only time the crew sees fresh fruit and fresh vegetables. So the crew is always very pleased to see it. Those are carrots. And imagine if you didn't see a piece of fruit for 4 months, you might want to just smell the fruit before you ate it. I asked a crew member one day, I got asked by a student in a classroom, can you blow bubble gum in space? So I asked the question. He took bubble gum to space, and so the answer is yes, you can blow bubble gum in space. Here's how you eat your M&Ms. All right, there goes the cream spinach, so nobody wants that. Here are the M&Ms. And here's throwing M&Ms into a ball of water. Here she's releasing a bag of pistachio nuts. So typical man sees food, opens mouth, eats food. She's a little bit more ladylike as she eats her nuts. Here she's making that ball of orange juice. So she squeezes the bag, the ball of orange juice comes out of the top, and then to separate it from the straw, she'll yank down on it. And now he's moving it around with a piece of dental floss. This is the NASA high-tech trash compactor. What do you do with the trash? We do not throw our trash into space. Nobody comes to the space station and collect the trash. So you have to keep it with you. On the shuttle, we would collect the trash in these bags and then compress the bag so it didn't take up a lot of room, and the shuttle would bring it all home. Shuttle flight lasted maybe 2 weeks. On the space station, they collect all the trash in the bag, and they wait for the cargo vehicle for 3 or 4 months to bring the trash back. This is your work desk. So here, you don't sit at a chair and work at a table, but you don't want your pens and your pencils and all your little things to float away. So each one of them is tied off with a piece of Velcro, attached with a piece of Velcro, so they're all there when you need them. This is the tool tray. So you can see there are a number of trays in this rack here, and in each tray, there's a big piece of foam. And the foam has a piece cut out in it so that the tool fits into each piece of foam so they don't float away. If you do no exercise on the earth, the fact that you walked upstairs, that you stand up, that you move around, you are exercising your body because everything you do, you're moving against gravity. So your muscles stay conditioned, your heart stays conditioned. When you go to space and there is no gravity, your muscles and your heart would get weak. You're fine when you're in space, but now you come back to Earth and there's gravity and you could be injured. So the crew exercises 2 hours every day on the space station. One way to exercise is in this bicycle. So he's a belt around his waist. His shoes are clipped into the pedals, and now he can pedal like on a normal bicycle. There is also a treadmill bolted to the floor. She wears a harness that holds her down to the treadmill so that she can run. And now this device lets you do resistive exercise, the kind of things you can do in a gym. So if he's getting ready to do a bench press, but you can do squats, you can do curls, you can do all of the kind of exercises you do in a gym. So 2 hours every day between these 3 devices, every crew member exercises. And it's part of their daily work schedule. During the World Cup, our crew had a soccer match on board too, proving why they should not be soccer players. Although I think this is a really interesting goal, who's going to keep going. You can see somebody running on the treadmill in the background. And here's a maneuver I don't think you see in soccer. We can bring our own books to read. We used to bring real books. Now we bring iPads with electronic readers on them. You can bring your own music on your little electronic device. There are some instruments on board that the crew can play. A guitar, easy to play when you float because you're holding onto the guitar. The keyboard here is tied down to the bag, and there's a battery in it so you can play the keyboard. And she's brought her own flute. Crew member who's going to launch in about a month says he's going to bring bagpipes. We'll see how that one goes. These laptop computers do everything for us now. They are our checklists, our procedures. They allow you to do email with friends and family. You get the news. You can get sporting events and movies. You can even use it as a telephone. So it brings up the 9 numbers of a telephone. You hit 9 for an outside line, and you can call anywhere in the world. So that the crew can call their family anytime they need to, day or night. Here's how you take a bath. Remember the water on his hand? Well, you put the ball of water on you. So you squeeze on a ball of water, spread it around. You take your washcloth and soap yourself. Squeeze on another ball of water, spread that around, and you take a towel, about that big, and you dry yourself. So that's how you take a bath. So you wash one part, and then you wash one part, and then you wash one part, and so on. So taking a bath takes a little longer. Shaving is normal, battery-powered razor or a straight razor. When the men started flying longer than a couple weeks, they wanted a haircut. How would you cut hair when hair would float away? So this device here cuts hair and then sucks it down a vacuum cleaner hose. Our Italian crew member has short hair, and she wanted to keep it short. So she took him, he's the commander of the space station, she took him to her hairdresser and made him learn how to cut hair. And he's been really good. He's cut her hair 3 or 4 times. He's cut the Russians' hair. He's cut everybody's hair. Well, not everybody's hair. This is toothpaste. So you have toothpaste and a toothbrush. You brush your teeth, just like you do at home. But there's no place to spit. So they tell you to swallow the toothpaste. Here's how we slept on board this shuttle. Everybody had a sleeping bag. You tie the sleeping bag off to the ceiling, the wall, the floor, wherever you want to sleep that night, and you get in, you zip it up, you take those big blue straps, which are Velcro, and you tighten them, and then you feel like you're tucked in. And whatever you don't tuck in will float. Now, because there's no gravity, the bed is not too soft, the bed is not too hard, your neck doesn't hurt in the morning, the blood doesn't run out of your arm so that your hand falls asleep. But if it's floating there, sometimes in the morning you wake up and notice a hand floating out in front of you. So tuck it in. Then you put your head on the pillow, which is a block of foam, and you strap your head to it. When you sleep at night, there's a position where you like to sleep. You like to sleep on your back or your side or your stomach. And when you put your head down, your neck is at rest. If your neck is at rest, the rest of you is at rest, and you go to sleep. On board the space station, each crew member has their own little compartment to sleep in, and it's little. It's the size of the sleeping bag and a little bit more. So she's in there, sleeping bag, she's all tucked up inside, and her personal laptop and she's got a drink bag in there and all of her personal items. So that is her bedroom. Okay, here's the toilet. So here's how it works, and it works the same for men and women. So you slide your toes underneath of those straps, pointing in that direction. You take the hose down from the wall for liquid, and you hold the hose in the right place. And when you start liquid coming out, you turn it on and it sucks the liquid down that tube, like a vacuum cleaner suction, where it is collected in a tank behind the wall. Then it is processed back into drinking water. Or as the crew likes to say, making tomorrow's coffee out of today's coffee. When we used to fly the shuttle to the space station, we brought the space station water 4 or 5 times a year. Now that the space shuttle is not flying, we recycle the water, both from our body and from the air, into water that you can drink, that you can rehydrate your food, and that you can break down into oxygen and hydrogen. So we've been recycling water and oxygen for years on the space station. Now, if you have solid material to collect, you open this lid here and you put a bag in that can, then you lower the lid and you hold yourself on the seat, because you would not want to float off the seat halfway through that. And you do what you're going to do. And then there are tissues and wipes, and you clean everything up and you put them in the bag. You close the bag, you put in a new bag for the next person. When that can is full of bags, you remove the can, put a lid on it, and put in a new can, and you wait 3 or 4 months for the cargo vehicle. Now, this is a Russian system, actually, but it's great. It does not smell, I promise. Some parts of the space station look like you might imagine a space station to look, nice and clean and tidy. This is the Japanese module. But most of the modules now have so many experiments and so much equipment that they look very crowded. And when the crew has to do work on some of that, then it looks really messy. And so the crew has to get into the middle of all of those wires and cables to do what they're doing. All of our supplies come up in these big white bags. And we have now so many white bags on board that sometimes you lose the crew. The experiments that we do on board station let us study things like how a material melts and re-solidifies if there is no gravity. So we have a furnace for that. We have a glove box that will let us study biological things or maneuver very small items around so they don't float away. We have a very cold freezer on board that lets us store samples to be returned to Earth later. We also have a little robot on board. And the robot has very flexible hands. So whatever you do with your hand, the robot can do. So you put on something that looks like a virtual reality rig, and when you move your hands and now move the legs, the robot moves the same way. One of our crew members decided one day to try to grow a zucchini plant. So he put the seed in a bag and he watered it, and outgrew a really long stem. Because without any gravity, it doesn't need to support its leaf at the other end. In fact, the leaf can support its own ball of water. And we are the experiment. Understanding how the body performs without gravity is important if we want to spend longer than 6 months in space and go farther away than our Earth orbit. So measuring her respiration while she exercises. The crew takes each other's blood. Now she's studying the pressure inside of the eye. Space station can also do spacewalks. 2 people get into their spacesuits and they go outside. Not only is there no gravity outside, there's no air and no pressure. So all of the air and the pressure is inside that suit with him. And in his backpack, he can stay outside for about 9 hours. And he has a safety line that is connected to a piece of structure. So it's like mountain climbing. You always attach to something before you unattach your line. We knew we would have crew members moving around the outside of the station. So all over the outside are these big gold handrails so that the crew can just move hand over hand when they're going, no matter how large the space station gets. We also have a robot arm that can move large parts of the space station around, or you can put a platform in there that will carry an astronaut with a large object to where he needs to be so that his feet are supported and he can work with both hands. If he comes out of that platform or the safety line breaks, in his backpack he has a little jet system. It isn't as good as what George Clooney had, but it's close. And that will let you fly back in order to grab onto a piece of structure or rescue your partner. And we have never had to use this, but we have tested it. Here is the ultimate space selfie. So he's outside doing a spacewalk. Here's the camera. The camera has its own little spacesuit. So here's the lens of the camera. Here are his arms. So that's a reflection of himself taking a picture of himself. And sometimes the crew just wants to play. This part of the space station is surrounded by windows, so it is a great place where you can literally watch the Earth go by or take pictures of the Earth, which is a very important part of our job. That picture of the Earth that I showed you as the first slide, that was taken from the moon, and you have to be all the way at the moon, 400,000 kilometers away, in order to see the Earth as perfectly round. Where we see, what we see on the space station at 400 kilometers is this view of Earth. So that's the view that we see. Some parts of Earth are very interesting. This is a glacier in the Andes. The waters of the Caribbean, in the Himalaya Mountains, volcanoes in Bolivia, sand dunes in Algiers, and the Namibian desert in the west coast of Africa. You could look at these pictures of Earth and convince yourself that the Earth is uninhabited until you see it at night. So some parts of the Earth are in fact recognizable. This is Italy. Remember, we have an Italian crew member on board, so she shoots lots of pictures of Italy. And sadly, you're not quite in the picture there. But here's Italy at night. And here, this is Serbia here, and so this is Belgrade right there. And you are here. In fact, a close-up, there you are, where you're right there. So we don't always point north all of the time. And here is Belgrade. Parts of the world are recognizable, like you see them on a map. This is the Strait of Gibraltar, the Sinai Peninsula, India and Sri Lanka, Florida, the United States, New York at night, Venice. People ask, so I show you Las Vegas. Las Vegas at night. Paris at night. Moscow in the snow. Tokyo Bay. Tokyo Bay at night. the Great Barrier Reef, the Hawaiian Islands, the Mississippi River. Here is the Mississippi River, and this was the BP oil spill. So you can see the things that we do to our Earth. The Amazon River, the Nile River, and the Nile River at night. We go around the Earth once every 90 minutes, and every astronaut from every country who has flown has come back and said the same thing. As you go around the Earth, you do not see borders and boundaries that separate the countries. We learn borders and boundaries when we learn geography. Each country is a different color. So you do not see natural borders and boundaries. What you do see is man-made borders and boundaries. This is the lighted border between India and Pakistan. These are the shadows from the pyramids. In this picture here, this is China, this is South Korea, and this is North Korea. Think about a map next time you see what it is. These are fishing boats, all these little dots of light by Bangkok. The Grand Canyon. Himalaya Mountains. Mount Everest. Mount Etna. And Mount Fuji. The crew likes to take pictures of interesting patterns. These are contrails, airplane contrails seen from above. Looking at agriculture around the world in South America, agriculture happens in these round areas called center pivot areas. So they take a long bar and they swing it around in a circle where it irrigates the land. And so you can see all of these round areas. The green is where crops are being grown, and the brown is where crops are not being grown. We see the same thing in Saudi Arabia now. Each one of these is a circle of area that is using fossil water from the center of the earth to irrigate the area. So when the water has been used up from that part of the earth, they are the light green ones, and then we see these things spreading around Saudi Arabia as the years go by. Here in Serbia, you have lines of agriculture. This is a hurricane. You write down the eye of a cyclone. And a cyclone as it dissipates. A thunderstorm. Each flash of light there, that's lightning. And you see this line across the top, this is Earth here, this line across the top, that's the top of the atmosphere. So all the air we breathe is below that line. And where we fly on the space station really is only about that far off the Earth. We're not very far away. Like I said, we go around the Earth every 90 minutes. So for 45 minutes the sun is shining, and for 45 minutes it's dark. And that line between where it is daylight and where it is night, that's called the terminator line. And because we go around the Earth 16 times a day we see the sunset and the sunrise. This is the aurora, which you see in the southern hemisphere and the northern hemisphere. You see the aurora right up at the atmospheric line. And because there is no atmosphere, there's no light pollution, you can see more stars than any place where it's dark on the Earth. In fact, you can even see the arm of our Milky Way. So that's what that is. So that's the space station as we fly it today. Real picture of the space station. And we'll fly the space station until 2020 or maybe a little longer. So that's what we do in space today. Where will we go in the future? I don't know. In spaceflight, we have been using the same technology for 50 years. Where is that true anywhere else? In nothing else do you continue to use the same technology. But in spaceflight, we do. So we have been in orbit around our one planet with 6 trips to the moon that ended in 1972. That's the last time we were at the moon. So I will give you my opinion where I think we should go next. And I think we should go back to the moon. It takes 3 days to get to the moon and 3 days to get back. So if something breaks or something goes wrong, like in Apollo 13, you can come back fairly safely. But if we could learn to go to the moon, put a base on the moon, learn to repair our own hardware, learn to produce our own food and water, then, practicing that close to home, we could go to someplace like Mars. It takes 6 months to get to Mars. And then you have to stay on Mars for 1.5 years before it only takes 6 months to come home. So you don't get to turn around and come back from Mars if something goes wrong. Mars actually has atmosphere that's made of carbon dioxide. But if you mix carbon dioxide with hydrogen, you get methane. Methane is fuel, so you could make fuel on Mars. Mars has gravity, has 1/3 of Earth's gravity. So you can jump 3 times as high on Mars, so things will stay where you put them. They think they found water ice on Mars, and if you can get ice out of the land, then you have oxygen, and then you have water. And it's not so far away from the sun that you can't use solar energy. So Mars, you actually could have a very rough outpost on Mars. The problem is how you get all of your equipment to Mars. So this is what we have currently put on Mars. These are 2 normal-sized guys standing in California. This is the size of the Curiosity rover. That's as big a thing as we have ever put on Mars. So until we learn to put considerably more mass on Mars, no one is going to Mars to live. This is the size of the Spirit and the Opportunity. Still, that's Curiosity taking its own selfie. You could actually build a base on Mars, but it will take longer than those Mars One guys think it's going to take. It will take a while to do that. But Mars is about the limit of where our rocket technology can take us. It simply takes too long to get anywhere else. 37 years ago, we launched a little satellite called Voyager. Voyager's plan was to go to the very end of the solar system, out past Pluto, past all of our planets. 37 years later, it's not there yet. So getting past Mars is very hard, but one day, when there is technology that will let us do it, and I don't know when that will be, then we could visit the other planets of our solar system and the moons of the planets of our solar system, or outside our solar system into our own galaxy, or beyond our galaxy into other galaxies. These are pictures from the Hubble telescope of different galaxies that are interacting with each other, stars that are dying, and nebula where new stars are being born. This picture taken from the Hubble telescope is from a piece of sky that's just a thumb covering a piece of sky, so a tiny little piece of sky. Each point of light in that picture is not a star. Each point of light is a galaxy. Think about that. Billions of galaxies in this one little piece of sky. In the whole universe, billions and billions of galaxies, and each galaxy with billions of stars, and all of those stars with billions of planets. So when people ask me, why would we ever go to space? I have to say, why would we ever stay home?